Well, FMT100, yeah, we're still in Unit 1, and this one happens to be electrical safety. So, electrical safety is kind of hicky because uh, we can't really see electricity. Um we can hear electricity every once in a while. Uh, Ideally, we should not be tasting electricity. We shouldn't touch or feel electricity. Um, yeah, we shouldn't smell it either. So, we shouldn't use any of our senses for that. So it's a little hard to see what's going on with it. One of the things we need to do though is we need to make sure we have the proper attire, the proper PPE. Now the good news is we already have most of that. We've got the hard hat, all right. Safety glasses, we'll definitely need those still. We're going to need some type of gloves, depending on what we're doing. We may need electrical gloves, or we could just use our regular leather gloves or whatever gloves you're using, all right. So it all depends on what we're doing, and your workplace will have a full procedure for all that. We're just going to go over some generalities. The other thing we're going to do is we're going to make sure we have the proper clothing. So we are in an industrial type atmosphere, even if you're doing just HVAC on an industrial scale or even a commercial scale. Um, our clothing needs to be flame resistant. All right. No, you don't typically have to go out and buy the full FR stuff, the flame resistant rated clothing. All you need is natural fibers. So cotton is the best way for us to go. All right. If you have to, fine. You can do a cotton polyester blend, but you never want to go um, too far away from 50% cotton to 50% synthetic. All right. Here's the deal. Natural fibers, so cotton, wool, linen, silk, all those when they burn, they turn to ash and fall away. Synthetics melt and stick to you and continue to burn. So that's why synthetics are not uh, recommended or not preferred, and in some places even outright banned. You can't wear them on the workplace. All right, so got that out of the way. So we want to wear natural fiber clothing, so cotton, and yes, that even goes all the way down to the underwear. All right, boots, good old leather boots are the best bomb for that one. And ideally, our boots should also be electrically rated, so they provide insulation for us. Uh, we're going to want to do lockout, tag out, and lockout, tag out. Everybody's all, they'll say lockout, tag out, and they're doing it as two separate things. It's not. The book even addresses it as two separate things. In reality, it's not. Lockout, tag out is a procedure. It is a procedure to isolate any energies that could cause harm to the maintenance personnel. That's us, folks. So that's what lockout, tag out is, a procedure to remove any potential energies that could cause us harm. And I'm using energies in a very broad term. So everybody's familiar with electrical, but there's still pressure, there is still movement, there's still compression through like springs and hydraulics, there's still uh, just water force. I know that sounds kind of odd, but there's still water force. So, and even the really odd one is potential energy from height. So if you got something that would fall on you and it's part of the mechanical process, you need to find a way to secure that as well. So it is lockout tagout is a procedure to secure and remove these hazards. So you can disconnect electrical, you can close valves and close two valves, and even remove piping if you have to reduce the problem of chemical energy, potential energy through pressure, movement, all of these things. So there is a method to isolate all those. Now, lockout tagout happens to be the last bit of that, where we can put on our lockout areas of securing whatever, light switches, valves, breakers, disconnects. We can put a lockout device on these points of the system, and then our options, we can either put a lock on our device, or we can put just a tag, or we could put both. We could put a tag on the lock and then put the lock on the device. And I wish I had better examples. We'll be going over that during a chat and cry. That's what I'm hoping to do. All right. So uh, we'll have these two means, a lockout device, and then we can either put a lock on it or a tag. Your tag is still perfectly legal. It takes a little bit more dedication from the crew. At the refinery, all we did, we used just tag out. That's all we did. And it worked perfectly fine. We all saw a tag. We knew what the tag meant. We just didn't mess with it. If we needed to operate that piece of equipment, had a tag on it, we found who put the tag on, and we asked them what was going on with it. And if it was out, if that piece of equipment was out of service, we just couldn't use it, and we'd had to go around it. So there's that. So going back to electrical, and you start working with electrical, you need to make sure you've got a nice wide space to work in. You don't want anything that would cause you to trip and fall into the electrical area. You also don't want people to be walking in and around you, because if for whatever reason they bump you, you could get tagged into the electrical system. If you happen to accidentally get tagged into the electrical system and you reach out and grab somebody, they're now tagged into the electrical system. So you want this buffer zone between you and the rest of the world. One of the ways to make sure that you don't get caught up into an electrical problem is to work on de-energized equipment. And the only way you're going to know for sure if it's de-energized is you are going to have to test for voltage. And the good news is there is a lab right after this page on doing just that, voltage testing. And I will demonstrate a couple different voltage testers, non-contact, contact, just a voltage tester, and a digital multimeter. So all of that is going to be done. Kind of see if I can slide a show and tell of some lockout devices for electrical, and we'll go from there. So in order to work safely on electrical stuff, the electrical system has to be de-energized, and you need to verify that yes, it is de-energized and it is safe to work on. And whether you're working on de-energized or energized stuff, if you happen to need a ladder, you're always going to use a non-conductive ladder, and the best option for that is going to be a fiberglass ladder. All right. So there's far more on electrical safety that we could go into. I encourage you to take FMT 104 and 105. They go further into that, but at least you got a general idea what's going on right now. If you're going to have to work on a piece of equipment, you're going to want to remove all the potential sources of energies from it. You want to make sure it's safe, and you're going to test to make sure that it's safe electrically. And we're going to show you the different types of equipment you can use for that. If you're wondering, well, how do I know if it's, there's safe for pressure? Well, you put a pressure gauge and see if there's pressure. Chemistry, you're going to have to see, and you're going to have to use some tests to determine if it's safe to do it. So I can't say for certain on everything because every situation is unique. You're going to have to follow your company's procedure for that lockout tagout, and each piece of equipment needs to have its own lockout tagout procedure. Now that said, they could be the same, but each piece of equipment is going to have a lockout tagout procedure. Just follow it and keep your head about you and focus on the task at hand, and you'll do all right. In the meantime, let's get ready for that lab, and we will go from there.